Hi physics students, we are about to begin the most important lecture of the entire year. And the reason for that is you are going to get to know all of the equations that we are going to use, and we continue to use them all year long. So please, 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 watch the whole thing. Work along with it. Hit pause. Make your calculations along with me to make sure that you understand what you are doing as we go along. Alright, so just at the very beginning, a quick reminder, time is delta t, measured in seconds. Distance, something can move in the x direction, delta x, or it can move in the y direction, delta y. Velocity, we have two different velocities. Your initial velocity is vi, your final velocity is vf, both measured in meters per second. We also kind of use them interchangeably, the word speed as well. And then finally, acceleration measured in meters per second squared. It's how fast you get faster. Are you speeding up or are you slowing down? For most of our problems, you'll need to know the acceleration. Objects falling towards the Earth's surface, the A is always a given. It is equal to gravity. Here, using the metric system, gravity is negative 9.8 meters per second squared. Negative 9.8, that is on your equation sheet under motion in one dimension right by the little car. What that means is that as something falls, it gets faster and faster and faster. It increases its speed by 9.8 meters per second every second. The negative does not mean less than 0. You can't have a speed that's less than 0. Anytime you see a negative in physics, it means you're in the downward direction. So you're increasing by 9.8 meters per second every second in the downward direction. Okay, at time 0, your speed would be 0. But after falling for 1 full second, if we neglect air resistance, you would have a speed of 9.8 meters per second. After 2 seconds, you would increase it by 9.8 to get 19.6. And then if you continue falling for 3 seconds, it would increase by 9.8 again to 29.4. So every second that you fall, you're getting faster. Okay, here are your different equations that we'll use, and once again, they're on your pink sheet under motion in one dimension. The first one, I have it off to the right side where it says constant speed only, v equals delta x over delta t. We use this very rarely. In order to use this, you cannot accelerate, you cannot change speed, you cannot speed up or slow down. We don't get to use it much. Starting on the left side of your equation sheet and moving right, the first equation, A, acceleration, is vf minus vi over delta t. Then we move into our distance equations. We can use them to solve for any of those variables. It is the same equation, I just have it solved once for delta y if you're going vertically and once for delta x if you're going horizontally. They are equal to vi delta t plus 1/2 at squared. Finally, the last equation uses the different velocities. Vf squared equals vi squared plus 2a, and then it's either delta x or delta y, depending on which direction that you're moving. How do I know which equation to use? If you're moving at constant speed, you get to use the little baby equation. That doesn't happen very often, so you just have to work your way through and see which equation you have enough information to solve for. Tips for helping you solve problems. Anything moving downward is negative. This is strange. Your height can be negative. Once again, it doesn't mean it's less than 0. It means it's moving in the downward direction. So anything that's about to fall, automatically we make the height negative because it's going to be moving in the downward direction. Acceleration is that negative force. It pulls in the downward direction always. Velocities can be that way as well. Sometimes you know some of the velocities right away. If you start at rest, you're stopped, your initial velocity has to be 0. If you're moving and then you come to a stop, your final velocity is going to be 0. And if you throw an object up, it slows down, hits the top at 0, and then speeds up as it goes back down. So the speed at the top is equal to 0. If an object is dropped, automatically we know 2 things right away. Vi is 0. You don't have an initial velocity before it goes. It takes a split second to speed up. So that initial velocity is equal to 0. And it falls because of gravity. So A automatically is negative 9.8 meters per second squared. And then finally, time up equals time down if you throw and catch it at the same spot. So if I throw this up, the time it takes to go to the top has to be the same as the time it takes to fall back down. Okay, so if it takes 6 seconds to go up and down, to go just up, it would be half. So it's just 3 seconds. We are going to jump into some problems. On the back side, we're going to work through a few problems together, and then I'm going to turn you loose, and you're going to be turning these in and submitting them in Schoology to get a few points. Problem 1, Olaf drops his stick arm from a height of 1.4 meters. How many seconds will it take to reach the ground? Because the stick falls downward, we have to make delta y negative. Okay, so in order to set up a problem, I absolutely need you to, we call it the GUE, G-U-E. I need to know what you were given, what is the unknown you're solving for, and what equation are you using. Especially since you're Digital Academy students, I can't look over your shoulder. I have to see those 3 things written out for every problem. The givens, there has to be 3 numbers in a problem in order for you to be able to use any of the equations to solve for it. Okay, sometimes they're a little bit hidden and you have to kind of find them. So as I look through here, I just always start by writing down what was given. Olaf drops a stick arm from a height of 1.4 meters. Height, up and down, is delta y. So delta y is 1.4 meters. I do need to make that a negative, and that is only because it's gonna, if you forget, it's not the end of the world. But we put that negative in there as we do the math, it's gonna cancel out another negative, and it's gonna help us be able to take a square root. So, from there, I don't have any other numbers. But, if I look at my front side again, I know that for all falling objects, 2 things are given. Automatically, we know the VI is equal to 0, and the A is because of gravity, so it's negative 9.8. I now have 3 different variables to start with, 3 givens. If I have 3 givens, I can use an equation to solve for what I need. I am looking for how many seconds, that is time, so my unknown is delta t. I'm going to work my way through my equation sheet. I'm going to just slide back here. I need to find t, so I have to use one of the equations with t in it, but I have to use my other variables. There can't be any other unknowns. So if I start with this equation right here, A equals VF minus VI over delta t, I can use it to solve for t. If I know these other 3, I didn't start with the VF. I don't know what the final velocity is, so I can't use that one. The only other equation, there's A, so I can't use this. The only other equation with t in it is this one right here. I have a delta y, I have a VI, and I have an A. I can use that equation to solve for t. So my equation, and I'm just going to write it up on the top so you guys can follow along. Delta y is equal to VI delta t plus 1/2 AT squared. From here, first thing I always do, if anything was 0, get rid of it in your equation, make your math easier. So as I look at it, VI is 0. Anything times 0 is 0. So if VI is 0 and it's multiplied by t, this whole thing chunks out and it all is equal to 0, so it's gone. I don't even have to put that part into my equation. Okay, so I'm going to drop that out to start with so that I don't get confused and throw any numbers in there. Then I'm going to start plugging in numbers. Delta y is negative 1.4. I'm going to set that equal to, this is gone. Can't put a t in there, it's multiplied by 0, it's gone. So on the other side, all I have is 1/2 times negative 9.8 times t squared. Some of you will be able to just pop that in your calculator. Others of you need to condense it a little bit more. So if that's the case, I just start by, all 3 of these are multiplied, multiply those 2 together, and you get negative 4.9 times t squared. To get t alone, I need to divide the negative 4.9 to the other side. So divide both sides by negative 4.9. It cancels out. My negatives cancel out. And I take 1.4 divided by 4.9, and I'm just gonna move it up to here, and I find that t squared is equal to 0.286. This is not my final answer. That is t squared. I need t. So my last step, I need to square root both sides in order to get my final answer, and I find that t, if I take that square root, is 0.53 seconds. All right, if you had forgotten this negative sign here at the very beginning, what ends up happening is it carries through and there's a negative sign right there. That is fine as long as you know you got to be smarter than your calculator. Your calculator will tell you it cannot take a square root of a negative number. You then just have to make that number positive and take the square root of it anyways. You can't let your calculator get the best of you. You have to then square root it anyways. Just make it positive. All right, moving on to problem 2. Perry the platypus accelerates at a rate of 1.5 meters per second squared from rest for 25 meters. Find his final velocity. So I'm looking through. I'm looking for 3 numbers in order to start. I have an acceleration, so my A is 1.5 meters per second squared. I am starting from rest, which means my VI is equal to 0. And my distance, if you couldn't tell that this was distance, look at the units. Meters has to be a distance. My delta x is 25 meters. I am looking for the final velocity, so my unknown is VF. And then I just have to work my way through my equations until I find one that has VF in it. So as you look through your different equations, only 2 of them have VF, and one of them also needs t. So that A equals VF minus VI over delta t, that first equation, I don't have a time. I can't use that equation to find VF. So then I shift 2 down to the VF squared equals VI squared. I'm going to write it up here. VF squared equals VI squared plus 2A delta x. I have VI, I have A, and I have delta x. I can use that to solve for VF. All right, first thing I do, get rid of anything that is 0. VI is 0. Get rid of VI squared. 0 times 0 is equal to 0. Then I plug in what I already know. So I'm solving for VF. It doesn't come as VF, it comes as VF squared. I just have to use that equation. Is equal to 2 times the acceleration, which was 1.5, times the delta x, which was 25. If I do a little multiplication, if I take 2 times 1.5 times 25, I get 75. That's not my answer. That's not VF, that's VF squared. So my final step is to take the square root of it, and I end up with 8.7. And then you have to pop a unit on the back. It's a velocity, so it's meters per second. Part B is a continuation of part A. How many seconds will it take him? You don't have to rewrite all of that stuff right there. You just, it's a given, it just carries through. The only thing we need to know is what is the new unknown? Seconds is a time, so that is delta t. And which equation should I use in order to solve for it? Technically, you can use 2 different equations. I just always use the easier of the 2. So the one that I'm going to use is A equals VF minus VI over delta t. All right, I got to plug in numbers from up here, plus I have VF right there, and I'm going to use that to solve for t. So A is 1.5. I'm going to set that equal to VF, which is what I just solved for, 8.7. You might have rounded it differently than me, that is okay. Minus VI. VI was 0, so that's gone. You don't even have to put that 0 there. Over delta t. Unfortunately, that t is on the bottom, which means I got to do a quick cross multiplication and then divide in order to get t off the bottom. I got to take 1.5 times t and set it equal to, ignore the 0, 8.7. I then have to divide by the 1.5 to cancel it out, and to get t alone, I have to take the 8.7 divided by the 1.5 because I had to cross multiply and divide, and that gives me a final answer of 5.8 seconds. All right, from here, I'd like you to pause the video and read through problem 3. See if you can figure out your givens, your unknown, and which equation to use. Okay, I'm going to keep moving forward. I'm going to get you set up on just those pieces, but please, please, please try to do it on your own first, and then pop back in and check your answer. So pause, try, see if you can find the 3 givens. Problem 3, Scooby-Doo is trying to catch up to the rest of the gang. He's traveling at an initial velocity of 16. My VI is equal to 16. He suddenly slams to a stop, which means my VF is equal to 0. If it takes him 1.25 seconds to stop, that's a time, delta T. Calculate his deceleration, which is just acceleration that comes out with a negative number. So my unknown is A. I am just going to pop up to the top with my equation. I am going to use, as I look through, if I want to solve for A, the easiest equation was this one I just used up here. A equals VF minus VI over delta T. I have all the information to solve for that, so that's what I'm going to use. All right, VF is 0 minus VI of 16 divided by delta T. A equals negative 16 divided by 1.25, which gives me a negative answer. A negative acceleration means you are either slowing down or falling downward. In this case, it means you're slowing down, and I got 12.8 meters per second squared. Check to see that you got that to work out. For the final problem, once again, pause the video now, please, and see if you can come up with your givens, your unknown, and your equation. And then from there, what I'm going to do is I'm going to put the final answers on here. So you're going to have to work your way through and show me that you can get to that final answer before you submit it. You are only going to submit the backside. I'm going to look just at problems 1 through 4 and get you 4 points for that. SpongeBob drops a rock off a cliff. It takes 3.5 seconds for it to hit the ground. I have a time. Calculate the final velocity. That's my VF. I have to have 3 numbers to start. I got to remember that it is a falling object, so that my initial velocity is always equal to 0, and my A is always equal to negative 9.8 meters per second squared. I am going to figure out what equation to solve for, and then when I get the correct answer, it is going to be negative 34.3 meters per second. So here is the final answer. You're going to make sure you can get the equation to check out, and you're going to get that for your answer. And then, once you have it in meters per second, you're going to do a conversion and convert it to miles per hour. You are then going to take your answers, and you're going to plug it in to solve for delta y, looking for which equation to work with. And your final answer for delta y, it will come out negative because it's going to be moving in the downward direction. Just comes out negative. It is going to be a negative 60 meters. So you'll know you've done it right if you get to the final answer of negative 60. Send me questions if you have any. Make sure you get those last problems finished. Then you are going to submit only the backside, just the 4 problems on the backside. Thank you. Please let me know what I can help with.